Hello. So this is a video I'm creating about data structures. I'm gearing it towards the CSE 12 data structures and object-oriented design class at UCSD. So just to start off, this is an introductory video just kind of explaining what data structures are, why we use them. So let's say you're a teacher and you have a bunch of students and you want to keep track of all of their grades and whatnot. You need some type of a data structure, a structure that holds data to hold your information. You could be a teacher, you could be an engineer, no matter what field you're in, you need some type of structure to hold your data, and that's called a data structure. So just from that, we can intuitively think there's a couple of functions that our structure should have, and these are functions that are shared by pretty much any data structure, give or take, depending on what the structure is. So I'm going to be talking mainly in terms of Java, so I'm going to be saying methods from now on, just to get that clear. In MATLAB, they're called functions. In different programming languages, they're called different things. But in Java, they're called methods. So one method that our data structure should most likely have, or definitely have, is some type of an add method. I'll start with a different color. So I'll say blue. So I'll take out the singleton. So we should be able to have some empty data structure that we create, and then we should be able to add elements to it. That makes complete logical sense. There should also be some type of a remove method. And then the remove method would, if we can add stuff to a list, we want to be able to remove stuff to a list. That makes intuitive sense as well. So if we think about it, there's multiple ways that we would implement an add and a remove method. Maybe we want to just take one parameter that's the element itself and we just add it to the end of the data structure. Maybe you want to take two parameters for add and have it be the first parameter being an index and the second parameter being an element. So then maybe we would add an element at a specific index. And then for remove, similar thing. There could be two different approaches for the most part. Maybe remove method, maybe one version takes as parameter an object, and then we check, does this object exist? If it does, we remove it. And then another implementation might be, without actually knowing what object we're removing, if we're given an index as a parameter, removing whatever object is at that index. These two seem like the main fundamental things that any data structure should have. A third one that would be useful, which you see in any data structure, would be some type of a size method. So if we have a list, if we have whatever you want to call our data structure, and we added some elements, we removed some elements, we did complex stuff to it, I should be able to see what the size is or how many elements there are at any given time. That also, it should make pretty intuitive sense. Instead of having to, if you're given a big list of data, usually one thing that you do is count how much data you have. Well, for this, we would use the size method. And then a fourth one that we generally always have would be a contains method. So a contains method is useful for if we have a data structure that has some number of elements, we don't know how many, but it doesn't matter. Our contains method should take a parameter, some object of whatever type we're holding in our data structure, and it should cycle through all of the elements of the data structure, and if the object exists, it should return true, and if the object doesn't exist, it should return false. That makes sense. Maybe we want to see, maybe the data structure is a list of students enrolled in a class, and I want to see, is Billy in the class? I would do something like contains Billy using Java syntax. Let's say my list object is called myL. So myl.contains Billy. If Billy is in the class, it should return true. If Billy's not in the class, it should return false. So I'll erase that. So as you're going to learn in my other videos, and more importantly in the CSE12 class, there are many, many, many types of data structures. Each one has its own pluses and minuses. Now, it has its benefits and its not so good aspects. Pros and cons, I should say. So depending on what situation we're in, one data structure will be better for us than another one. And as you go through the class and learn about the different data structures, you'll be essentially building up your own little toolkit so that when you're in the real world, you know, oh, this is my situation, I should be using this data structure and whatnot. But yeah, this is just a basic overview. This is pretty much what data structures are.